quantity which has both magnitude as well as the direction. We call it as a vector. But vector, when it is a function, right, we should be able to apply every function that we can apply a vector, able to, right, what you call operation that you are able to do it on variable, you should be able to do on vector, because now vector becomes a function. So in that, on that concept, right, we try to look at a curve PQ, right, and if P is a position vector, right, then you add a delta R to that, you get a new vector. So as this OP gets added with the delta R, you get a R plus delta R, right? We can try to represent that particular function, right, using the normal vector notation. R is equal to x into I cap, y into j cap, plus z into k cap. All right, now if there is a time variable that decides the position of this vector, right, in other words, if we are able to decide the position vector's location by using a variable t, right, the parameter which decides the point P, how it traces along the curve, then you see that vector R becomes R of t. It's a function of time, right? Now we can apply the differentiation formula to that. So dr by dt should be possible. Okay, that is denoted by r dash of t. It's a vector. So limit delta t tending to 0, the change in the time interval, you try to reduce it to 0, and you try to calculate the difference r of t plus delta t minus r of t whole divided by delta t. Okay, using this concept, we understood that when the delta t tends to be 0, or when we make this sorry, delta t function as 0, we can understand that the delta t which was present, it's going to be very close to 0, so that, right, the line or the vector dr by dt is going to touch the given curve only at one point, right, at particular point P. So dr by dt will represent a vector along the tangent. So if we relate this to the basic concept which we had studied earlier, this is nothing but the slope along the tangent. So slope of the tangent was obtained if you differentiate a function. Okay, this is what we studied earlier. But now if you have a vector r and if you try to differentiate that, what you are going to get? You are going to get the vector along the tangent. So in other words, you get a tangent itself, it's a vector, okay, at that particular point P. Okay, so the concept is you have a vector, you differentiate the vector, and what you get is a vector along that direction. Now what we do, we extend this concept to velocity and acceleration. If at all we have a curve represented by r, right, that's a vector, if you differentiate that at a given point of time, the vector v is equal to dr by dt, which is velocity. So just remember this point. If you have been given a r, differentiate that r to get a v, velocity. Now from physics we also have studied that the a acceleration can be obtained by differentiating the velocity. So now the same thing should be applicable here as well, because what we are trying to do here is, right, there is a vector v. I should be able to differentiate that because vectors can be differentiated. We just have understood that. So d by dt of dr by dt, which is d square r by dt square, is the acceleration. Then we saw all these kind of notations. You can use either the variable t inside the brackets, or you can actually neglect that and you can. So coming to the properties of the differentiation, if there is a sum, you can apply the differentiation and then you can separate the sums. First you can apply the differentiation to each vector, then you take a sum. Similarly, it goes with the differentiation and the difference. So we saw that. Then we went to the scalar product and the differentiation. How? Because in vectors we have two types of products. One is a scalar product. What happens to the scalar product? This is the proof, right? So d by dt of f dot g vectors is equal to f into dg by dt plus df into dg by dt. Okay, sorry, there's a mistake, so this is not plus. I'll correct that. So this is a dot product. Okay, then going further, we also have proved that what happens with the vector product. So cross product is f cross dg by dt plus df by dt crossed. Okay, that's the concept studied. Then we try to recall what we already have studied in basics of mathematics in the vector chapter. So how do you find out a component of one vector along another vector? That is, you just have to take a dot product. It's a component, it's not a vector, so you don't have to take a cross product, just a dot product. So that is a vector dot n cap, unit vector. So what's a unit vector? It's a d vector by its magnitude. So whenever we do that, we get the answer. Similarly, component of a vector perpendicular to a given vector. So when you say it is perpendicular, this particular concept has to be, right, this particular point has to be a vector. So my result is a vector. Okay, so when I say the result is going to be a vector, now you see what we are going to do here. We subtract something from a and it's going to be a vector. How do you find out a vector? So a vector minus n cap, right? A vector dot n cap is a scalar component into n cap. So into n cap gives you a vector. So a vector minus that vector is a vector. You can take its magnitude if you want a component. If you want to find out the vector, then you don't have to write a magnitude. Without that, whatever you write itself is the answer. Are you okay? So that is the concept. So then we went to the concept called as unit vector, right? Normal to a given curve. Space curve is some given curve, right? So where we initially calculate a tangent vector, differentiation of the tangent vector gives you the perpendicular component. That's what we understood. So t cap and dt by ds are perpendicular to each other. So which means if you want a perpendicular vector and it is unit vector, then n cap is the answer, which is dt by ds, right? Is a unit vector, is a vector divided by its magnitude. So n cap is equal to dt by ds divided by magnitude of dt by ds. So this component is called as the principal vector normal. So I have not given the name. Now I'll write the name. This particular component is called as the, this is principal vector normal. Okay, if at all it is useful, we might use this. Okay, now let's go to the problem based on what we discussed in the previous topics. All right, so this is the question. So if x is equal to t square plus 1, y is equal to 4 times t minus z. Okay, it's not z, it's simply 3, sorry. 4t minus 3, and we have the next component, that is z is equal to, this is 2t square minus 6 times t. Okay, so this is a given representation for the curve, right? Find part A of the question, unit tangent vector. Unit tangent vector at any point on the curve. Okay, then let's write another concept. This is angle between the tangents at t equal to 1 and t is equal to 2. So at t equal to 1 and t equal to 2, right, we have to find out what is the angle. Alright, so let's start with the problem. I know that I am supposed to write a vector r. Okay, vector r is equal to, this is x into I cap plus y into j cap plus z into k cap. So I'm going to substitute that now. So this is t square plus 1 into I cap plus this is 4 times t minus 3 into j cap. Okay, plus this is 2t square minus 6t into k cap. So this is actually, you can call this as r of t. Representation is one and same. Now how do you find out the tangent vector? We know the basic concept. So tangent vector is denoted as, so that is, let's write it as capital T vector, which is nothing but the dr vector by dt. Differentiate this r with respect to t. So t vector is nothing but, so you see that there is a t square plus 1, differentiation is 2t. 2t into I cap. You see that you cannot differentiate the unit vector, so I cap remains as it is. Okay, so plus the second term y is there. Y is nothing but, it should be 4t minus 3. I should write dy by dt. So dy by dt is just 4 times j cap, right? Then plus, so 2t square is 4t minus 6t, differentiation is 6 into k cap. So this is the tangent vector. But if you look at the question says that find the unit tangent vector. So how do you find the unit tangent vector? Therefore let's write unit tangent vector. Let me denote as t cap. T cap is equal to vector t divided by magnitude of vector t. This is from very basic concept, right, of vectors. So that is, let's write the vector t as it is. So what is vector t? Vector t is like this. So 2t into I cap plus 4 times j cap plus 4t minus 6 into k cap whole divided by, so if you remember the concepts of taking the magnitude of a vector, then it has to be square root of every term squared. So 2t squared is 4 into t squared plus there is a 4 square is 16. Okay, then plus this is 4t minus 6 the whole square. Okay, now let's try to simplify this further. So this is t cap is equal to, so this is 2t into I cap plus 4 into j cap plus 4t minus 6 times k cap whole divided by, so this is square root of, let's expand the term. So this is 4t square plus 16 plus, see 4t minus 6 whole square is a minus b whole square, so a square is 16t square plus 6 square, which is 36, and we have 4 into 6 is 24 into 2, so this is minus 48 into t. So the unit vector can be substituted as this now. So that is 2 times, okay, I can see that the 2 is common over there. I can take out the 2. Alright, so that is, if I write 2 outside, then this becomes t into I cap plus 2 times j cap plus 2t minus 3 times k cap whole divided by, let's try to write the denominator, 4t square plus 16t square is 20t square. Okay, then I have the term containing t, that is 48 into t. Then the constant is 36 plus 16 is plus 52. Okay, now so I can try to simplify this in the following fashion. This is t cap. So if I take a 2 outside, anyway, the 2 outside which is already there, let's write as it is. This is t into I cap plus 2j cap plus 2t minus 3 times k cap whole divided by, from the square root I'll take 4 outside because 4 is common, but when 4 goes out of the square root, 4 becomes 2. So 2 root of, right, I am taking 4 outside from the square root, so root of 4 is 2. That's why. So 4 5s are 20. So this is 5t square minus 12t plus 13. Now you can see that the 2 will get cancelled. So your final answer, you find the unit vector is given by t times I cap plus 2 times j cap plus this is 2t minus 3 times k cap divided by root of 5t square minus 12t plus 13 is the unit vector. Okay, unit tangent vector. That's the first part of the question. Let's just go back to verify this. Yeah, so part A is unit vector, unit tangent vector at any point. So how do you change the point now? You can substitute different values of t. So the second question, you see, angle between the tangents at t equal to 1 and t equal to 2 seconds. So how do you do that? Now find out the t at different intervals of time. So let's try to write that. At say t equal to 1, find out what happens to the t cap. I'll call this as t1 cap, that is equal to, every t is 1. So this is simply I cap plus 2j cap plus this is 2t, 2 into 1 is 2 minus 3 times k cap whole divided by, let us substitute. So this is 5 minus 12 plus 13. Alright, because t is equal to 1. Alright, so you can see that this is going to be the I cap plus 2j cap minus k cap 2 minus 3 whole divided by, this is square root of 5 plus 13. So 13 minus 12 is 1. So this is root 6 is the first vector. Okay, I can similarly find out the second vector, that is at t equal to 2. So at t equal to 2, let's call this as t2 cap. T2 cap is once again calculated in a very similar fashion. So that is 2 times I cap, because t is equal to 2 now. So plus 2j cap plus this is 2 into 2. So 4 minus 3 times k cap whole divided by square root of, this is now 5 into 4, 20 minus 12 into 2 is 24 plus 13. Alright, so this now becomes equal to t2 cap is equal to, this is 2i cap plus 2j cap minus k cap whole divided by, this should be root of 20 minus 24 is minus 4 plus 13 is 9. So that is 3. Okay, so anyway, one is the root 6, other one is divided by root 9. We got two vectors. Now let's recall the concept of the dot product. So what is a dot product? Dot product is nothing but, we already know something, that is, if you write t1 cap dot t2 cap is nothing but magnitude of t1 into magnitude of t2, okay, into the cos theta. I know that magnitude is already 1, right? I don't have to write the magnitude of t1 t2 now. So simply you can write the cos theta is equal to t1 cap into t2 cap divided by magnitude of t1, so divided by magnitude of t2, which is 1. So simply I can write t1 cap dot t2 cap, right? So let's do that now. This implies the cos theta is nothing but, let me write the t1 and t2 which already we have written here. This is I plus 2j minus k. Let me write that. This is I cap plus 2j cap minus k cap by root 6 is the first one. Okay, and the second one is 2I cap plus 2j cap minus k cap divided by root 9. So this is nothing but, denominator you can see that root 9 is 3, so I have 1 by 3 into root 6 into I into 2. So I need to multiply only I into I terms. So I into I is 1, so 2 into 1 is 2, plus 2 into 2 is 4, okay, minus 1 into minus 1 is also plus 1. So this is numerator is 7 by 3 root 6. So if you calculate this value, so this comes to be 0.9525. So cos theta is that. This implies, let me just verify the product once. T1 is minus k and T2 is also minus k. Okay, 1 plus 2 minus 1, 2 plus 2 minus 1. Okay, so this is what we get. So theta should be cos inverse of 0.9525 is the final answer. Okay, we can calculate this and write the angle if needed. All right, let's go to the different question now. The next question is like this. Find the unit normal vector to the curve r is equal to 4 sine t into I cap plus 4 cos t into j cap plus 3t times k cap. So you can see that this can be first once again written like the r of t. Okay, but let's write the required formula. Now you see the question is find the unit normal vector, in the sense find the perpendicular vector. So which concept is that? Perpendicular vector is this. You can see here unit vector normal to the space curve, in the sense my answer is n cap is equal to dt by ds divided by dt by ds magnitude. So we are going to apply that particular formula now. So let me write the formula directly here. So that is n cap is equal to dt cap by ds whole divided by magnitude of dt cap by ds. This is what I am supposed to find. Okay, now let us try to write first the t cap. So how do you find t cap? T cap is differentiation. T cap is what is t cap? T cap is unit tangent vector, right? For that, first I need to find the tangent vector. Anyway, so let's start with the r now. So r is equal to 4 sine t into I cap plus 4 cos t into j cap plus 3t times k cap. Now, how do you find the tangent? Tangent is equal to dr by dt. Okay, so dr by dt is nothing but 4 differentiation of sine t is cos t into I cap. Then I have the second term coming up, which is a cos function. So differentiation is minus 4 sine t into this is j cap. Okay, and the last term is plus 3 times k cap. This is what? This is the dr by dt, which is the tangent. So when you have a tangent, now we can find the unit tangent, that is t cap. So t cap is equal to, how do you find t cap? The t vector divided by magnitude of the t vector. So t vector we just have it now. So that is 4 cos t into I cap minus 4 sin t into j cap plus 3 times k cap whole divided by under square root. This is 4 cos square t plus 4 sin square t plus 9. Sorry, 4 becomes 4 square. Please correct. This is not 4. This is 4 square, so 16. Alright. So this is 16 into cos square t, 16 into sin square t plus 9. Okay. Now I can apply a trigonometric identity to get this answer quickly. So that is, let me write the numerator as it is. That is 4 times cos t. This is 4 cos t I cap minus 4 sin t j cap plus 3 into k cap divided by under square root. This is 16. I'll take it out. What you get is cos square t plus sin square t. Okay, plus 9. So this implies we know that cos square theta plus sin square theta is equal to 1. So I just cancel that. So root of 16 plus 9 is root 25, which is 5. So the whole term becomes simply 5. So what is your final answer? I can write 1 by 5 into this is 4 cos t I cap minus 4 sin t j cap plus 3 k caps. Okay, this is the unit tangent vector. Now, what do I need? I need the differentiation of this, correct? So my intention is like this. I need to calculate the dt cap by ds, which is nothing but, let's go back and check the formula. We already have discussed that. So how do you find out this? So dt by ds, I need to calculate the dt by ds. So this function dt by ds is nothing but differentiation of this t cap. You can see here dt cap by dt divided by dr by dt. So anyway, I can directly write that formula here now. So this is nothing but dt cap divided by the dt. Okay, this I can write whole divided by, this is magnitude of dr by dt, its magnitude. So what is dt by dt? dt by dt, in the sense I need to differentiate this function, correct? So differentiate that function. So 4 cos t becomes minus 4. There is a 1 by 5 outside. Okay, so I'll simply write 1 by 5. Then you differentiate the above equation t cap. That is 4 cos t becomes minus sin t. So this is minus 4 sin t I cap. Then minus 4 sin t is there. Minus 4 sin t differentiation is minus 4 cos t into j cap. So 3 is there, its differentiation is 0. So whole divided by, now you see it's a magnitude of dr by dt. So dr by dt, we can check that here. If you see the magnitude of dr by dt, which is the magnitude of your t cap, right? So I'm going to show you with the color now. So this is dr by dt. Dr by dt is nothing but t. So magnitude of dr by dt is nothing but this, right? That is this denominator. But I already have showed that denominator value is 5. So simply I can write this as, already we have calculated, so simplify. Okay, you can follow the same procedure and get the same answer once again. But since we already have calculated that, I am simply replacing that value as 5. Okay, so magnitude of dr by dt is nothing but magnitude of t itself, which is calculated as 5 already. Okay, now this implies, let's try to simplify this. So this is dt by ds is 1 over 25 times minus 4 times sine t into I cap, right? Okay, I can make the minus outside. Let's make everything positive. Plus 4 cos t into j cap. Alright, so even the 4 can go outside. You can simply write this as minus 4 by 25. This is sine t I cap plus cos t j cap. Alright, now this means I need the magnitude of this because I have to use that as the n cap. Therefore, this is magnitude of dt by ds is equal to, if you see this is the 4 by 25 remains outside, magnitude of 4 by 25 into square root of, this is sine square t plus cos square t. I know that sine square and cos square t sum is 1. So magnitude of this is simply 4 by 25. So what is required now? Therefore, the final answer, that is n cap, is equal to, this is dt cap by ds whole divided by magnitude of dt cap by ds. Both of them we already have now. So this is minus 4 by 25 times, this is sine t I cap plus cos t j cap whole divided by 4 by 25. So you know that 4 by 25, 4 by 25 cancels. So unit vector is nothing but minus of, this is sine t into I cap plus cos t into j cap is the final required answer. Okay, all right. Okay, let's just discuss this once again. So the question is find the unit vector to this given curve. Curve is r vector is 4 sine t I cap plus 4 cos t j cap plus 3t times k cap. Alright, so this is given and my answer is n cap. Okay, n cap is given by dt by ds whole divided by magnitude of dt by ds. Okay, then what is t is the question now. T is nothing but the tangent. T is a tangent, t cap is unit tangent. So I need to find the unit tangent first. So we start writing down the r equation here, right? We know that r is given by this one. Okay, this is the r. So then we proceed further by using the equation for tangent, that is differentiating this given r. So when you differentiate r, I'm going to get 4 sine t becomes 4 cos t, I cap as it is. Cos t becomes minus sine t, so second term is minus 4 sine t into I cap, sorry j cap, plus 3t becomes 3 into k cap. That is the tangent vector. But now you see, when you have the tangent vector with you, my next objective is to find the unit tangent vector. So how do you find a unit tangent vector? Divide that vector by its magnitude. So t cap is equal to t vector divided by its magnitude. Alright, now once we have that with us, our objective is to substitute the values and get the answer. So I write the t vector on the top and find its magnitude in the denominator. That is this part. Okay, so once you have that, now what we do, now we can simply calculate the remaining values by simplifying the denominator. Numerator as it is, 16 is common, cos square plus sin square theta is 1, so that's what I have written here, right? Further, let's simplify. That denominator is root of 16 plus 9, which is root 25, which is 5. That 5 I am writing it as 1 by 5 over here. Okay, numerator is written as it is. So 4 cos ti minus 4 sin tj plus 3k. Okay, now we need to find out the dt by ds first in order to substitute in our equation of n cap. So what is dt by ds? Yesterday we have written this equation. The dt cap, differentiation of t cap with respect to t by the magnitude of dr by dt. Dr by dt is your tangent vector. So I know its magnitude is already written in the denominator, which is 5. I can simply copy that. Okay, all right. So same thing we have done here. D t cap by this can be obtained by differentiating the t cap, which is just above this. So you can see here there is 1 by 5. 1 by 5 is written. 4 cos t differentiation is minus 4 sin t. Then we have the next term, which is minus 4 sin t. Differentiation is minus 4 cos t. So differentiation of next term 3, which is a constant, is 0. So we don't write that. Divide by denominator is 5, which is nothing but the magnitude of dr by dt. Magnitude of dr by dt is magnitude of this, which is in the denominator. You can see 5. That 5 itself can be written. Now, once you simplify this further, you can see that the magnitude of that dt by ds is 4 by 25. So substituting in this equation, the vector which you got is this, divided by the magnitude is this. So 4 by 25, 4 by 25 gets cancelled, right? And we get the n cap, which is the required unit normal vector, is like this. First step, our intention is that I need to find the t cap first, correct? So in order to find the t cap, what I do, I find the vector t now. So t vector is equal to, this is dr by dt. So what you get as dr by dt is minus cos t differentiation is minus 2 sine 2t into I cap. All right. Sin t is positive, so this is plus 2 cos 2t into j cap plus t differentiation is 1 into k cap. Correct? So this is the t vector. Now I will calculate the magnitude t here itself so that I can calculate the value at a later stage. So this is minus 2 sine 2t the whole square. Correct? So this is 4 into sine 2t sine square 2t plus this is 2 square, once again 4 into cos square of 2t plus there is 1 here, 1 square remains 1. Correct? So you can see this now, this is under root 4 into sine square plus cos square is 1 plus 1. So the magnitude of t is equal to root 5. Okay, so we got that now. So when this is the case, I get my t cap, which is equal to, what is t cap? T cap is equal to vector t divided by magnitude of that vector t. So this is the vector t is already there. I have to divide this by, so 1 divided by root 5 into that vector minus 2 sine, minus 2 sine into 2t into I cap plus 2 into cos 2t j cap plus k cap. So this is what you get as a t cap now. So what is my next requirement? My next requirement is I am supposed to calculate this same function, and I am supposed to calculate the dt by ds. So how to calculate the dt by ds? So that is dt cap by ds is nothing but it is dt cap by dt whole divided by magnitude of, that is dr by ds. So dt cap by dt can be calculated by simply differentiating the above term. So that is 1 by root 5, you keep as it is. Differentiate the above function once again. So minus 2 as it is. Sine 2 differentiation is 2 cos. So this is minus 4 cos 2t into I cap. So cos becomes minus sine. So minus 4 into, this is sine 2t into j cap. So k has constant 1 over there, differentiation becomes equal to 0. So divide by, you can see that I have to divide this by the dr by ds, which is nothing but the magnitude of t here. So what is dr by, my mistake, this is dr by dt, okay, not s, please make a correction. This is dr by dt. Dr by dt magnitude is magnitude of t cap, which is root 5. Okay, I have to divide this by root 5. So that means this is root 5 and 1 by root 5 and 1 by root 5, it becomes just 5 now. So 1 by 5, right? I think there is a minus 4 common. I can write a minus 4 outside. Minus 4 by 5 into, this is cos 2t plus cos 2t into I cap plus sin 2t into j cap. Okay, this is what is the function now. So this is dt cap by ds. So I want the n cap. N cap is nothing but dt cap by ds whole divided by magnitude of dt cap by ds. So this is minus 4 by 5 times cos 2t I cap plus sin 2t into j cap whole divided by, see the magnitude of this is nothing but 4 by 5 cos square 2t sin square 2, which is 1. So I can, it's just 4 by 5. By just observing we can write here, and I can see that they will get cancelled. So when they cancel, we get the n cap like this. N cap is equal to, which is minus of cos 2t I cap plus sine of 2t into j cap.